the problem tells us we have vertices of 2, 2, negative 2, 2, negative 2, negative 2, and 2, negative 2. So the figure is rotated 45 degrees counterclockwise, so now it's going to look like that. And part A wants us to find what complex number we multiply to produce this transformation. So I'm first going to find this distance between, which is from the origin to one of the old vertices, and I'm going to do that by using the Pythagorean theorem. So I'm going to square root both sides, and that's going to give me 2 root 2. So that is the old dilation factor, or whatever you call it. And the new one is just 2. So I'm going to put that over 2 root 2, and the 2's are going to cancel out. So I'm going to get 1 over root 2. And then I'm going to multiply both the top and the bottom by root 2 to get rid of the radical on the bottom. And so I'm going to get root 2 over 2. So that is the dilation factor. And now to get the complex number, I'm going to do cosine of 45, because that's the degree. And then I sine of 45. Cosine of 45 is root 2 over 2. And so is sine 45. Okay, so now I'm going to distribute the root 2 over 2 to everything. So if I multiply root 2 times root 2, that's going to take away the radical. So I'm going to get 2 over 4, which is 1/2. And then if I do the same thing, I'm going to get 1/2 I. So this is the answer to number part A. This is the complex number that the programmer is going to multiply to get that transformation. Okay, part B wants us to basically square this whole thing. So, like before, if I square root 2 over 2, I'm just going to get 1/2. And since 2 isn't inside the parentheses, I'm just going to multiply 45 times 2. So cosine 90 plus I sine of 90. And that is the answer to part B. So the dilation factor would be 1/2, and then it would be rotated 90 degrees.